All right, what's going on, nerdy scholars? Here we go. This should be pretty rad, like it's cool. Do math like it's cool. Yeah. All right, so going on to now section 4.6, and the title of this section is Graphs of Other Trig Functions. And last section, we covered the sine and the cosine function, right? So we learned how to graph sine of x, and we learned how to graph cosine of x with all of their shifts and compressions and stretches and all the likes. So now we want to go to the other ones. And the other ones are going to be tangents, cotangents, cosecants, and secant. So this section is kind of beefy. Get ready to get buff right now because we're going to do a few examples of tangent, a few examples of cotangent, cosecant, secant. So, and this is all bundled into one section here. So there'll probably be a lot of examples, which is good for you. I just highly encourage you to, pause the video at times so that you can write the material down and then just go and listen as I'm explaining things and taking notes, filling in gaps, and of course, write down questions that you're having that you can answer in class. Okay. All right. So if we're going to graph first the tangent function, just like we did with the sine and cosine, we need to have some points, right? Well, we don't know what the critical points are yet. And if you remember correctly, sine and cosine, we always started with the critical points, right? Well, it's going to happen the same way with all other four trig functions, but we don't know what they are. So let's just start plotting points. Let's graph it, and then we're going to derive what those critical points are. All right, so we'll just use theta and tangent theta. So let's just start with, with 0, and we'll make our way around the unit circle and plot them and see what we come up with. All right. All right, so let's find the tangent of 0. And just a little quick reminder here, tangents is the same thing as sine over cosine of theta, which is the same thing inevitably of y over x, right? Remember, it's the y coordinate over the x coordinate. So when I ask for the tangent of 0, well, I'm going to do 0 over 1, which is just nicely 0. Okay? Now, I could do what's tangent of pi over 6, and that's going to give me 1/2 over root 3 over 2, but we're going to get this gnarly fraction. Let's just do nice numbers, and so I'm going to skip to pi over 4, okay? So I'm going to take the tangent of pi over 4, and then you'll see why, because if I take the tangent of pi over 4, that's y over x, so that's root 2 over 2 over root 2 over 2. Well, that's just going to give us nicely just a 1, okay? So that's why I'm going to skip pi over 6, and consequently, I'm going to skip pi over 3 because it's the same thing. It's going to give me a decimal. I'm kind of just interested right now in just some nice numbers. So let's go to pi over 2 now. Tangent of pi over 2, well, that's y over x. 1 over 0. Undefined. It's not possible to divide by 0, so we'll see what that means graphically here in just a moment. All right, let's go on now to another pi over 2. So we went pi over 4, pi over 4 again, and let's go another pi over 4, which takes us to 3 pi over 4. And the tangent of 3 pi over 4 is negative root 2 over 2 over root 2 over 2, which is just a negative 1. All right, and let's do pi then, another pi over 4. And that's 0 over negative 1, which is just 0. All right, so right now we just did a half a rotation around the circle. We can keep going here, but let's just stop right there and let's just plot these and see what this comes out to be. And then hopefully we can maybe make some inferences here. All right, so let me just do something like this and like that there. All right, so we have 0, 0 right here, and we're going to be plotting pi over 4, pi over 4, pi over 2, pi over 2, and then 3 pi over 4, and lastly pi. So let's just see what this looks like here. Well, first of all, you see right here we have undefined, and this kind of goes back to what we learned about rational functions. If you ever have an undefined value, that's going to be an asymptote. So I'm actually going to put a dotted line at pi over 2, and so I'm going to kind of do something like this right here. Okay, and that's just because our graph can never touch right there because it's going to be an undefined value. All right, so let's go ahead and graph this. So 0, 0. Okay, so it's right there. Pi over 4, 1. So I'm going to make this right here 1. I'm going to make this right here a negative 1. So pi over 4, 1. And then pi over 2 undefined. So if we kind of look right here, this guy is going to kind of go up, and then it's going to approach it, but it never touches it, right? That's the purpose of an asymptote, is that it rides along it. So as the dotted line keeps going up, our graph, our tangent is going to keep getting closer and closer and closer, but yet never touch it. 3 pi over 4, negative 1. 3 pi over 4, negative 1. And then pi 0. Pi 0. Okay, so if you kind of look what we have here, this isn't looking too pretty here, but this is what we have so far, okay? If you're like, what the crap is that? I'd probably be asking the same thing. So it seems that our points are, what we grab, it's not quite enough, or can I say it's not the critical point. It doesn't give us really a true picture of the tangent graph. So what I suggest is this. Let's just keep going. Say if I went on, okay, so we did pi, now let's go to 5 pi over 4, so 5 pi over 4. Let's see what value I get right there. Well, 5 pi over 4, that's negative root 2 over 2 over negative root 2, so that's going to give us 1. Okay, so if I go to right here, 5 pi over 4, and that's going to give us a 1. So right here, 1 right there. So it's going to kind of go up like that. And let's go to another pi over 4, so that's 3 pi over 2. And let's see, 3 pi over 2. If I do y over x, oh, check that out. I get another undefined. So at right here at 3 pi over 2, I'm going to get undefined. So let's do another dotted line right there. So kind of go right here to another dotted line. So we have another asymptote. Okay, and so I'm going to go ahead and connect what we have right now and see if we can make some kind of inference. So it goes like this, and then it goes up. So let's remember, what is a period? A period is when you've done not necessarily one full cycle around our circle, but a period is when you've done one full cycle of our graph. Meaning, if you start right here, so right here, if I start here, then if I start back right there, that means I've done one full period. So from here to here is what we would call one period, because it started at 0, 0, and then it came back and then it went right there again. So a period right here would be from 0 to pi, or we would say a tangent graph has a period of pi. Now, basically the tangent graph is this right here, okay? And if I were to continue over here, this thing would just repeat again. And maybe if I were to just sketch that real quick, say this would be a negative pi over 4. This right here would be negative pi over 2. If I did my asymptote again, okay, so okay, if I did that, and then if I continue this, see, this is one period, this is a second period, and so this would continue going over and over and over and over and over again. So let's actually simplify this now, because yeah, we graphed two periods, but I want to now condense this to what really are the critical points, right? And basically, we're going to focus just all right here, okay? And once we graph one period, we can duplicate it either to the right or to the left. So let me just go to this slide right here and just show you. So here's what the tangent graph looks like. This looks a lot nicer than mine right here, right? I mean, if you kind of look right here, I mean, they look pretty much similar, but the one that's nicely computer generated looks a lot nicer there. So here's our tangent function, okay? And what I want to do down here is actually tell you now and compartmentalize what are the key points and what is it that we always start with. And so this right here is what we're always going to be referring to right here, okay? This is like our key points for plotting the tangent graph. So as you can see here, we're going to go from negative pi over 2 to pi over 2, which is why it has a period of pi, because from negative pi over 2 to pi over 2, it does one full cycle, and then look, it starts back over again. So that's why our period is pi. Okay, let's go through the critical points here. All right, we're going to start with negative pi over 2. And if you go to negative pi over 2 right here, okay, now if you go backwards, right, okay, so this is negative pi over 2, that's y over x, and so that right there is going to be undefined. That's going to put a u for undefined. Now we're going to go by increments of pi over 4. So this was our first one, so now we're going to go to negative pi over 4, which is really 7 pi over 4. Okay, so negative pi over 4, which is the same thing as negative 1, right, because y over x. And so negative 1. So that's why this is the point right here, negative 1. See? Negative pi over 4, negative 1. See? Go to another pi over 4, so we get 0. And the tangent of 0 is 0 over 1, which is just 0. And that's why if you see on the graph here, 0, 0 is our point. And now basically we're just going to duplicate this. Pi over 4 and pi over 2. The tangent of pi over 4 is just 1, because if I go y over x, and the tangent of pi over 2, as you can see here, is another vertical asymptote, so undefined. Okay, so here are what we call now the critical points. Okay, so this is what you really need to have memorized, or this is what you need to use every time that we're going to graph tangent. We're always going to start with these points, just like when we wanted to graph sine or cosine, we started with with our point 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, these are the points that we were always going to start with. Okay, and just to go down over here, if you want to know what the domain is, well, the domain is going to be every single x number except where? Well, these vertical asymptotes, and that's why I say so x equals, or it's going to be all real numbers except when x equals pi over 2 and then plus pi n, meaning I'm going to add, to go from this pi over 2 to this 3 pi over 2, I have to add pi, where n is an integer. So that means as I keep adding pi, I'm going to keep getting multiple vertical asymptotes, and so that's where our domain would not cover. Range is all real numbers. It goes forever to down and to the top. And lastly, the domain and the vertical asymptotes happen to be the same here. Okay, so that's basically the foundation of the tangent function. So now let's go on to some examples of tangents.